about some of that work
This meeting is being recorded.
To support sustainable marine aquaculture, particularly through the use of science in different ways. And I'm going to be touching on a bit of work that I conducted with the Nature Conservancy, which is a major environmental nonprofit that operates in the US and globally, as well as some of our work at NOAA. And so I wanted to start with just a little bit of background on who I am, a little bit about my background in the world of marine conservation and marine science and where I came from in the world. So I grew up in a small town, Gloucester, Virginia, which is on the York River. It's a tributary of the Chesapeake Bay. And growing up in the backyard of the Chesapeake Bay, I really from an early age became very aware of the environmental challenges that face the Chesapeake Bay. And also in my backyard, thankfully, was the Virginia Institute of Marine Science, which is the College of William & Mary's marine science lab and school. And what was really exciting about that fact was that I had an opportunity in high school and throughout college at the College of William & Mary to actually get a hands-on experience working on marine conservation and restoration science at VIMS. And at VIMS, I really got more deeply involved with oyster restoration science. Hearing about all the challenges facing the Chesapeake Bay, it was really exciting to me to see the power and the utility that science can really play, applied science can really play in addressing some of these environmental challenges like oyster restoration, like habitat enhancement, like ecosystem recovery, that we so desperately need in the Chesapeake Bay and other coastal systems around the country and world. I also was lucky to work with Dr. Ron Lipsius for my undergraduate work, who was actually the PhD advisor of Dave Eggleston, who ultimately became my own PhD advisor. So it's really a small world, and that link with Dave is actually what brought me down to North Carolina. See if I get the slides to advance here. There we go. And so Dave was running and is still running a really strong program in North Carolina focused on applied science towards supporting coastal habitat restoration in North Carolina. And that really excited me and drew me down to North Carolina, where I spent 2 years in Raleigh and about 2.5 years on the coast, working on both field and lab science to really understand the drivers of oyster restoration success, using a lot of that field work to really understand what those drivers are, and applying that information through model-based tools, GIS-based tools largely, to support development of decision support tools to aid identification of potentially successful locations for oyster reef restoration. So that work took a couple different forms. It took the form of doing some advanced meta-population modeling work to really simulate oyster population dynamics in Pamlico Sound, North Carolina, to really understand important oyster reefs within the system for conservation purposes, as well as developing geospatial tools like the one that you see on the right here, with groups like the Nature Conservancy and the North Carolina Division of Marine Fisheries, to really support effective oyster restoration efforts in North Carolina. And my PhD work really drove home to me and helped me to build the skill set to really understand and apply science towards better conservation and restoration efforts. And so as my PhD work was coming to a close, as Dave mentioned, there was this really interesting opportunity that popped up at NOAA, focused on exploring the role that shellfish and seaweed aquaculture in particular, so the farming of shellfish and seaweeds, the role that those activities may play in providing ecosystem services. And so it was this really interesting position. Like I mentioned, it was a joint one between NOAA and the Nature Conservancy, that was based between the NOAA's National Ocean Service, a group based at the Beaufort Lab in y'all's backyard, North Carolina, and the Nature Conservancy's Global Aquaculture Program, which is based at the Nature Conservancy's headquarters in the DC area. And so as you've heard, I have been really focused on shellfish restoration, focused on conservation, focused on sort of that aspect of coastal ecosystem recovery, and hadn't paid as much attention to the world of aquaculture. But I was really intrigued by this notion that shellfish and seaweed aquaculture could potentially play a role in supporting ecosystem recovery objectives. Just knowing, the importance of coastal habitat restoration, but also the challenges that sector faces in terms of, in the case of oyster reefs, we're at less than 15% of our global historic oyster reef distribution. So we really have a big challenge ahead of us in terms of coastal habitat restoration. And so it really made me think about, an all hands on deck approach towards reaching those outcomes of coastal ecosystem recovery. And so that was fascinating to me, this potential for shellfish and seaweed aquaculture as a different avenue, a different tool in the tool belt, using a private, market-based angle to support achievement of some of these objectives of ecosystem recovery. And so the more that I really began to dig into the peer-reviewed literature and really understand what that evidence base was surrounding the potential for shellfish and seaweed aquaculture to provide ecosystem services, it became clear there's a few main areas. And so those are shown on this slide here. When we're thinking about nutrient pollution, for example, in terms of eutrophication and the challenges associated with that in coastal systems, shellfish are taking up some of those nutrients in the form of the food that they're consuming, phytoplankton and zooplankton. And through physical removal of those shellfish through harvest, there's the potential for removal of some of these nutrients from coastal systems. There's also a growing body of work that the gear and the species that are farmed in terms of shellfish and seaweed aquaculture has the potential to provide habitat for wild fish and invertebrates, as well as supporting fish stocks through stock enhancement efforts that often use aquaculture technologies. And in the case of seaweed farming, there's been some really interesting work that's looked at the capacity for seaweed farms through photosynthesis, through the uptake of carbon dioxide, to actually provide some localized ocean acidification buffering benefits. And so this was really interesting to me in terms of this potential for these forms of aquaculture to really support our ecosystem recovery objectives. And in the global context, this is really important for a number of other reasons as we're thinking about our global seafood supply and global food production system. Aquaculture is growing and is going to continue to grow rapidly. So recently, aquaculture surpassed wild capture fisheries in terms of total seafood production. And it's by multiple estimates, one of the fastest growing food production systems on Earth. And so we know with wild capture fisheries that around the world, we are either at or are exceeding the capacity of these fisheries to supply additional seafood. And so as we think about a growing global population, the main way to meet that supply-demand gap is through additional aquaculture. But we also know that aquaculture has been riddled with environmental impact throughout its history. When we're thinking about shrimp farming, there's been extensive and expansive destruction of mangrove forests. When we're thinking about fish farming and shallow coastal water sites where it's often in many parts of the world conducted extensively, there's challenges with effluent impacts, there's challenges with animal health and welfare. So what this really boils down to, as we're looking at this plot out from 2020 to 2050, is a window of opportunity for us to really shift that trajectory of growth towards one of greater sustainability and to really learn from that history of aquaculture production to really shift this industry into a direction that is more positive and more sustainable. And so at the Nature Conservancy, we really began to dig into these questions around the potential ecosystem services role of marine aquaculture. And so as a trained ecologist, with my great NC State MEES training, myself and colleagues really wanted to dig into the state of the science regarding the potential for marine aquaculture to deliver these ecosystem services. And just to get us all on the same page, ecosystem services are effectively the services that humanity receives and depends upon from ecosystems. And so these are often grouped into categories of provisioning services, regulating services, habitat supporting, or cultural services. And so this study that I'm describing here, we focused on conducting a state of the science assessment to really understand what the peer-reviewed literature says about how marine aquaculture can deliver ecosystem services across these various categories, as well as what the conditions are that really influence the potential for aquaculture to deliver those services. And what we found was that marine aquaculture can deliver a wide range of ecosystem services, ranging from the more obvious services like production of food products to others like the ability to modulate and improve water quality. Talked a lot about that with the nutrient pollution mitigation example, to providing habitat for wildlife, as well as providing cultural services like employment and a sense of place. Beyond that, we dug deep and dove deep on the specific potential for shellfish and seaweed aquaculture to provide habitat value. And so we just recently published this study. It's a literature review and a meta-analysis that characterizes the state of the science related to the habitat value of shellfish and seaweed aquaculture. And so within this study in particular, we focused on characterizing the various mechanisms and drivers of habitat value. So I lay some of those out here in terms of just thinking about the foundational ecological principles that drive aquaculture towards providing habitat value in certain cases. These include things like food subsidies, so the species that are cultivated themselves can provide a food source to wild fish and invertebrates, as well as the gear providing structure and substrate for establishment of fouling communities that can provide sort of an artificial reef type community, or support an artificial reef type community in food web. Additionally, these structures and the gear can provide spawning habitat in terms of habitat for wild fish and invertebrates to be able to actually reproduce, as well as the ability of, in certain cases, cultivated organisms to reproduce as well, and in certain cases that can promote and support shellfish restoration objectives. In certain cases, we also see that as being a negative in terms of the potential for some of these species that are perhaps non-native to reproduce. So a little bit more complex on the spawning piece. Additionally, shellfish and seaweed aquaculture can provide refuge habitat, as we're thinking about the structures that are used in farming. There's a potential for refuge for juvenile fish and invertebrates using that gear, as well as resting habitat. When we dug into the meta-analysis portion of the study, we were able to draw from around 65 studies around the world to actually quantify and estimate the range of habitat value associated with different forms of shellfish and seaweed aquaculture, which really pointed us and we were able to produce the first global numbers of the effects of shellfish and seaweed aquaculture on wild fish and invertebrate abundance. So I have that shown here in this plot. I've got another infographic on the next slide that shows it in a little bit simpler of a format. And so this infographic really boils down those results into a simpler visual representation. But the main takeaway here was that we found that shellfish and seaweed farms on average hosted a greater abundance of fish and invertebrates than nearby reference sites without aquaculture. And so in the case of mussel farms, for example, we saw a 3.6 times greater abundance of fish and invertebrates at farm sites relative to reference sites, with a range of other enhancements associated with other forms of aquaculture and similar patterns in terms of diversity. And there's a lot to disentangle here as we're thinking about the challenges of production versus attraction. Are these enhancements just attraction of other organisms from other habitats, or are we seeing additional production? And to begin to dig into that question, we recently published this other study that expanded and built upon that meta-analysis that I just shared, focusing on quantifying and developing economic values or estimating economic values specifically for nutrient removal and habitat provisioning services of shellfish and seaweed aquaculture. And so this work really built upon that study that I just shared. We were able to put some numbers on what those or what that habitat value is, and begin to put more scalable numbers on the nutrient removal and habitat provisioning services of shellfish and seaweed aquaculture. And so this was and is really the first set of global numbers around what that value is in terms of shellfish and seaweed aquaculture. And so for bioextraction, as we're thinking about nutrient removal services of shellfish and seaweed aquaculture, we found that there's an average of 275 to 581 kilograms of nitrogen per hectare per year that's removed from coastal water bodies through oyster, mussel, and seaweed aquaculture. And that's worth somewhere between 84 to 505 US dollars per ton in locations where nutrient removal is a management priority. When we're thinking about the habitat structure provided by aquaculture, that's estimated to support somewhere between 350 to 1,000, around 1,000 kilograms per hectare of additional fish, potentially worth somewhere between $1,000 to $2,500 per hectare per year to commercial fisheries, or between $1,000 and $3,000 per year to recreational fishers. And one really important point to capture here is that these services are effectively a side effect of farming. These values are coming from studies that have just compared existing commercial aquaculture operations to nearby reference sites. So this is really exciting as we're thinking about these specific forms of aquaculture and the potential and capacity of these forms of aquaculture to be supporting other ecosystem services of value to society, like commercial fisheries, like nutrient removal. And so that's a lot of great academic work, but aquaculture is an industry, and we really need to be thinking about how this information boils down towards supporting improvements in aquaculture activities to maximize habitat benefits, to maximize other ecosystem services, if we're really going to be moving towards aquaculture as being a tool for aiding ecosystem recovery. And to support this, there was a global task force that was brought together by the Nature Conservancy and a white paper that was published last November that really boils down this science into a set of roadmaps that are useful to policymakers and farmers to really understand what forms and specific practices are likely to provide what are called restorative benefits to coastal systems versus those practices that are more likely to be impactful to coastal systems. And so these roadmaps, the white papers at this link here, really lay out in a very simplified format, what some of these practices are that move you into these more restorative or not likely restorative categories. Thinking about things like, are you, in your farming practices, are you removing existing habitat? Are you farming an invasive species in cases along those lines? Or in this not likely restorative category. However, when we're thinking about systems where there has perhaps been habitat degradation, these may be systems that would benefit the greatest from aquaculture as a tool to support some of that ecosystem service delivery. So in addition to that, there was work. This was actually the work that I began in that joint position between NOAA and the Nature Conservancy, trying to ask the question of if there are these benefits, in fact, available through aquaculture, where is the potential for these benefits the greatest? Where should we be really focusing and thinking about development of aquaculture to seize this opportunity to provide these benefits? And so what we did was we conducted a global scale spatial analysis that brought together a whole suite of different global scale data sets to really help us to identify which ecoregions, essentially distinct marine regions around the world, have the greatest potential for development of shellfish and seaweed aquaculture to provide these benefits. And so we brought together environmental data sets, thinking about where challenges related to nutrient pollution are greatest, where challenges related to fishing pressure are greatest, as well as data sets around some of the socioeconomic conditions. Where is regulatory quality strong enough that good regulations can be put into place to ensure a sustainable aquaculture sector develops? Where is food security a challenge? And then on the human health side, thinking about some of the constraints, thinking about harmful algal blooms, thinking about the prevalence of wastewater treatment, as well as other pollutants of concern. And how did we actually do that, or why did we do that? So we know that shellfish and seaweed aquaculture, as I've shared, has the potential to serve a role in enhancing food security, producing food products and other products that are useful for local communities, as well as novel employment opportunities. But we know that development of sustainable shellfish and seaweed aquaculture can be hindered by inadequate governance. I gave the examples earlier where we've seen a number of challenges associated with the environmental impacts of aquaculture. A lot of that's due to poor regulation and poor management, as well as insufficient infrastructure. So if we're thinking about wastewater management, for example, we could be producing seafoods through aquaculture that are unfit or unsafe for human consumption, especially when we're thinking about shellfish. And so what all of that really means, as I said earlier, is that really where shellfish and seaweed aquaculture develops is key to maximizing the social and environmental benefits of these activities. And so the objective of this specific study was to identify regions around the world where shellfish and seaweed aquaculture has the potential to mitigate some of those environmental challenges. Again, gave those examples of nutrient pollution, habitat loss, as well as providing maximum societal benefits. And we did that at the scale of marine ecoregions. So these are, in blue here, these are distinct marine regions around the world. And so our spatial analytical approach focused on first identifying relevant factors to incorporate into the analysis. This was a challenging step because there's many different factors that of course are relevant when we're thinking about this specific question. But we needed to have solid global data that was representative to be able to incorporate and use in this analysis. The next step was bringing in and actually assembling, processing, and standardizing that spatial data. Gathering expert input to prioritize the factors, actually getting input from stakeholders within the sector, across governments, academics, the actual industry, to help us to prioritize those various factors for use within the analysis. And then integrating all of these factors and this data within a GIS-based suitability model to prioritize various regions. And so for that first step, again, we had factors representing environmental considerations, like the status of coastal habitats, thinking in this analysis about areas where coastal habitats are most degraded as being where shellfish and seaweed aquaculture could perhaps provide the greatest benefit in terms of providing habitat, thinking about issues like ocean acidification. Again, examples being where seaweed aquaculture has the potential to provide some localized benefits in terms of buffering against ocean acidification. And then other socioeconomic factors, again, food security, thinking about logistics performance is one factor, thinking about how efficient logistics are within a country in terms of the ability to actually manage a sector from the private sector perspective, as well as factors along the lines of human health, again, things like wastewater treatment infrastructure. We don't want to be thinking about prioritizing shellfish aquaculture, for example, where there's a lot of challenges related to wastewater management. And so the next step beyond that in terms of developing those factors was actually assembling, processing, and standardizing the spatial data. This was perhaps the most challenging aspect, one of the most challenging aspects of the study in terms of gathering the best available and most representative data at the global scale. But our process was to effectively obtain global data sets. In this case, we're looking at a data set of ocean acidification vulnerability, converting that data set to the eco-regional scale so that we could get all of our data onto a common spatial scale, common unit, determining a suitability relationship. And what this really does is brings all of these individual factors into a consistent scaling. So in this case, we're thinking about specifically ocean acidification vulnerability from the perspective of where is the potential for seaweed aquaculture to provide those localized buffering benefits. Where's that potential the greatest? And so in this case, we're thinking about areas where there's high levels of ocean acidification vulnerability as being those areas that are most likely to benefit from growth of seaweed aquaculture to provide some of those benefits. And so that we then apply that suitability relationship to that global data set at the eco-regional scale and reclassify it using that relationship. And what that gets us to is a data set that shows us areas of low to high opportunity for development of aquaculture to provide those specific individual benefits. And so we did this for each of those individual data sets within our analysis. What that ends up looking like, as I mentioned, is a layer like this. In this case, we're looking at regulatory quality, areas of high regulatory quality being areas where there's the greatest opportunity for growth of a sustainable shellfish or seaweed aquaculture sector. These are regions and countries where there is strong ability for government to manage the private sector in terms of regulations. Low opportunity indicating countries where there are countries and regions where there are challenges with managing the private sector within those regions. So how did we actually collate this information into an overall model that allowed us to synthesize across all these factors and identify, across all these different considerations, where is the highest and lowest opportunity for development of restorative shellfish and seaweed aquaculture? So the way we did this was we gathered expert input to actually prioritize these factors and used a weighted model system to achieve this, where each of the individual factors that were used in the model were assigned a weight. And so these weights across all the different factors sum to 100%, and a higher weight indicates a factor or consideration that was deemed more important in driving areas of opportunity for growth of shellfish and seaweed aquaculture. So in this case, extent of habitat degradation received a weight of 23% and was really an important layer in identifying areas where development of shellfish and seaweed aquaculture could support ecosystem services. How did we actually gather that input to assign those weights and to prioritize those different factors? We brought together a panel of experts that represented input from nonprofits, from academia, from government and industry to really get a full cross-section of perspectives and input to prioritize these different factors and to actually assign those weights to the individual factors in the model. What did that look like? So across the various layers and factors included in the model, again, thinking about environmental, socioeconomic, and human health factors, we ultimately worked to utilize the average weights after careful consideration of a few different options. We utilized the average weights across the input from the different experts. And that's what this ended up looking like. And so you can see in terms of the environmental factors overall, we have a higher weight towards those environmental considerations in driving the areas of opportunity for shellfish and seaweed aquaculture growth. But other factors across the board received differing weights based on their differing importance determined by the panel. And so when we integrate all of those individual spatial layers, we apply those weights from that expert panel approach. These are the maps that we end up with, which really synthesize across all of those different environmental, socioeconomic, and human health considerations to identify the regions around the world for both shellfish and seaweed aquaculture, where there's the highest to lowest opportunity for development of sectors to provide those restorative ecosystem service benefits to coastal systems, as well as benefits to coastal communities. And so when we dig deeper into the specific results, right here I'm showing the top 15 ecoregions around the world. When we're thinking about shellfish aquaculture in particular, there's quite a bit of opportunity that's identified in North America, in Europe, parts of Asia, as well as Oceania, which is quite interesting. But when we think about all of the factors that are funneling into this analysis, it's not terribly surprising. When we're looking at seaweed aquaculture in particular, we see similar patterns, but we see a lot more opportunity within Europe, some opportunity in Asia, South America, North America, as well as Oceania. But one important note as we're looking at these maps is that there's not a continent on Earth, aside from Antarctica, where there is opportunity identified for growth of shellfish and seaweed aquaculture. So this is really showing that there is a global opportunity here for growth of these types of aquaculture to provide these benefits. And so the big picture and utility of this specific approach is that it really provides a novel conceptual framework regarding the ecosystem service value of aquaculture at the global scale. This helps us to really dial in and think about, as we're looking at this, global sector, global industry that's anticipated to have a global growth trajectory. Where is there the greatest potential for growth to provide these ecosystem services to coastal communities? And the analysis itself is being used in a few different ways. One is at the Nature Conservancy. It's being used to help identify and inform priority regions for future aquaculture development projects. And it's also been used in varying ways to help inform, even here in the United States, some of our efforts targeted towards growth of aquaculture. And so now I want to step back a little bit. I showed that figure at the beginning of the global growth trajectory of aquaculture, and kind of want to put aquaculture back in that global food production system context. And so the plot to the right here shows global animal protein production. And what's really interesting and perhaps a little surprising to us in the US is that seafood is already a significant contributor to global animal protein production. It's about 40% of all animal protein that's produced. And about 20% of that number comes from aquaculture. But when we look at the picture of aquaculture production by country, it's a really interesting story when we're looking at where the U.S. lands in this global context. So the U.S., as it stands now, is the 17th ranked country in terms of total aquaculture production. China is really at the top of that list by a long shot. They are the world's largest aquaculture producer. But what's interesting is that in the US, even though we are not a major aquaculture producer, we import over 70% of our domestically consumed seafood. And so since we're, in that case, we're not major aquaculture producers domestically, we are still major farmed seafood consumers. And so this is really interesting from the context of NOAA, and as we're thinking about national and domestic seafood production and consumption, in terms of this gap in production, particularly as we're thinking about that chart that I showed earlier, where we're seeing this potential in this plan really at the global scale for major growth of aquaculture. And so there's really this opportunity to potentially seize here to increase our production domestically. And some of the other drivers for us to be thinking about when we're thinking about all these different forms of animal protein production are the environmental performance, or is the environmental performance of our different food production systems. And so when we're thinking about beef production, for example, relative to finfish aquaculture, there's really quite a dichotomy in terms of the difference in greenhouse gas emissions associated with beef production relative to finfish, as well as land use and freshwater use. But there's also a major difference as we're thinking about the actual consumption of different animal proteins, particularly here in the US, where there's around 51.5 pounds consumed per capita of beef relative to 14.5 pounds of fish. So there's this big difference in what we're consuming in the US, as well as a big difference in the actual environmental impact of the forms of animal protein. So the main takeaway message here is that there's significant resource efficiencies, and this is really a major opportunity for us to seize in terms of, if we're thinking about environmental impacts of animal protein production, there's significant efficiencies, significant reductions relative to other forms of animal protein production with fish aquaculture, with other forms of aquaculture that we really need to be considering as we're thinking. And when we're thinking about what our marine aquaculture sector actually looks like right now in the US, it's mostly coastal nearshore shellfish aquaculture. So oysters, clams, and other forms of shellfish are really the predominant type of aquaculture in the US. It's largely small scale producers with some smaller amounts of finfish and seaweeds being produced. Our total industry as it stands is around $500 million in terms of total annual production. So relative to other major players in the world, it's relatively small, but it does play an important role in coastal communities in terms of livelihoods and even these ecosystem services that I've talked about. At NOAA and across other organizations, we're really thinking about that gap between where we are now and where we will be in an aquaculture future with growth of aquaculture production. And we're really envisioning a move towards a sector that is more sustainable in different ways, where we've learned from the challenges of the history of aquaculture production around the world, which really moves us more towards thinking about finfish aquaculture in particular in the offshore environment, where we're able to mitigate and eliminate, in some cases, the challenges around nutrient pollution, around the country. The main takeaway here is that most of our aquaculture production is coastal, it's near shore, a lot of it's shellfish, mostly oyster, mostly clams, and it's a relatively small sector by value and by total production. I had that slide showing the U.S. production relative to other countries around the world. We're thinking a lot more at NOAA and around the world about what future aquaculture production looks like. Showed that big gap in terms of future seafood demand and where that's going to come from. We know that if we have more shallow nearshore finfish aquaculture, we know if we have more shrimp aquaculture and mangrove areas, we're going to continue on that trajectory of environmental degradation, environmental impact. And so we need to be thinking creatively and using our tools through science and technology to move us towards more sustainable aquaculture production systems. And when we're thinking about finfish aquaculture in particular, that's in a lot of cases moving us towards more offshore locations where you have greater current flows, you have greater water quality conditions that can support more sustainable finfish aquaculture, not without any impact, but with less impact than when we're thinking about shallow nearshore areas. But with the use of more precise technologies like automated feeding, thinking about putting production closer to major consumption centers to reduce the travel duration, the travel distances that different seafood products are taking and having. When we're thinking about salmon aquaculture in particular, a lot of that gets flown in from Norway to Los Angeles or to New York, and with that comes a lot of emissions. So we need to be thinking about all of these different opportunities for science, technology, and just greater efficiency to move us towards a more sustainable sector. And we just recently published this paper, which is looking at the potential for emissions reduction and carbon capture in marine aquaculture. I showed that slide earlier that showed beef production relative to finfish production. And when we're thinking about feeds, we're thinking about land use, there are already significant resource efficiencies associated with aquaculture. That doesn't mean that there aren't opportunities for further enhancements. And there are also opportunities for some levels of carbon capture. And so in particular, there is a lot of interest right now from many different parties in the potential for large-scale seaweed aquaculture to provide carbon sequestration benefits. Alongside that interest and intrigue are a lot of research questions that still need to be addressed and answered. So this study in particular dives deep into what some of those opportunities are, what some of those research questions are that remain, and where we really need to go in terms of thinking about climate smart growth of aquaculture. That being said, we also need to think about when we're thinking about our seafood portfolio in terms of wild capture and aquaculture, there aren't very many levers that we can pull in terms of managing wild capture fisheries in light of climate change. There are certainly some levers, but there are fewer, and we're more at the mercy of natural systems. When we're thinking about aquaculture in particular, there's a number of different levers through science, technology, through management that can support greater climate adaptation opportunities. And a couple of examples of this are thinking about siting. We can specifically locate aquaculture operations in areas that minimize environmental and space use constraints, as well as thinking about areas where there's potential for resiliency in terms of sea surface temperatures, water temperatures, storm events, that sort of thing. There's potential for gear innovation. If we're thinking about the stormy Gulf of Mexico, there's potential through different gear types to actually be able to raise and lower different types of aquaculture gear to be able to withstand some of those storm events. Of course, that involves a lot of expense in terms of we're talking about very capital intensive forms of aquaculture there. As well as thinking about hatchery technology. And back in the early 2010s, not that long ago, out in the Pacific Northwest, there were major challenges with ocean acidification, with acidified seawater actually killing off a lot of larvae with oyster larvae within hatcheries. But what's developed since then has been the ability to actually buffer incoming seawater into some of these hatcheries with calcium carbonate to be able to balance out some of those challenges of acidified seawater. And so through hatchery technology, there's the ability for us to sort of nurture cultivated organisms through that most vulnerable stage of their life cycle as juveniles. So aquaculture, it's not a silver bullet solution here, but when we're thinking about our portfolio of seafood production opportunities, there's a lot of really unique adaptation opportunities that we need to be thinking about and seizing, particularly as we're thinking about resilient seafood production. So one effort that's underway at NOAA are what are called aquaculture opportunity areas. And so these were mandated through an executive order that was issued in May 2020, focused on improving American seafood competitiveness. And so this is a really consistent approach to what's been applied around the world in terms of marine spatial planning for aquaculture. Around the world, there's a lot of approaches that have been taken to develop what are called zones for aquaculture, which are effectively areas that have been really heavily planned and screened to identify areas where aquaculture activities are compatible. This is in that vein. It's a planning activity. It's not a regulatory activity, but it's effectively focused on identifying areas where there's the greatest potential for aquaculture development to minimize environmental impact as well as mitigating potential use conflicts. So this is an effort that's actively underway at NOAA. A lot of the work's being led out of NOAA Fisheries, but also with interactions with the National Ocean Service and folks actually in North Carolina at the Beaufort Lab. That effort that's underway at the Beaufort Lab actually was just published this past year. These aquaculture opportunity atlases were developed for the Gulf of Mexico and Southern California. What's really impressive is that they are the most comprehensive regional marine spatial analyses that we're aware of that's ever been conducted in U.S. federal waters. These analyses brought together over 200 different data layers for both regions, for the Gulf of Mexico and the Southern California Bight. Things like shipping channels, things like hard bottom habitat, a whole range of different considerations within these analyses to really identify where aquaculture, where growth of aquaculture sort of fits into that puzzle of existing ocean activities. So I encourage you to check those atlases out, whether you're interested in aquaculture or not. There's a lot of really valuable data contained within them. And as part of that process, there's really comprehensive stakeholder engagement, and these analyses really set the framework for future aquaculture opportunity areas. The executive order calls out a growth of these AOAs over the next decade or so, as well as this analysis framework really providing an opportunity to be applied for other ocean sectors. Additionally, beyond just that analysis, NOAA is conducting through the National Environmental Policy Act, NEPA, the development of programmatic environmental impact statements for these AOAs. And so specifically what that looks like is a really rigorous evaluation of a range of different environmental impact criteria for these specific areas. And the way that we're achieving that is through really leveraging and growing our capabilities across the country within NOAA in a variety of areas like social science, biosecurity, engineering, genetics, etc. And the way that that's really working is through, let's jump ahead a little bit here because I know I'm short on time, through the development of what are called science advice products. So you all as scientists know what this really is. We're thinking about literature reviews, we're thinking about models, and the objective here is really to develop specific products, science advice products, that synthesize that best available science, the best available information to support folks that are writing these environmental impact statement documents to bring together the best available scientific information. And so typically the way the NEPA process works, there's a NEPA writer that's having to go out and really be an inch deep and a mile wide in terms of their awareness of different environmental impact considerations. And this process that we're moving towards across those different categories of social science, engineering, allows these science advice products to really bring straight to the desk of these NEPA writers the best available science, so that the documents, these environmental impact statements, can utilize the best available information. And so just quickly, what that looks like in terms of science advice, it ranges from a variety of types. On the left side of the spectrum, we're thinking about things like subject matter expert consultation. That's one form of science advice. That's obviously a little bit more nimble there in terms of just consulting with a subject matter expert on a specific topic, but has less depth of information. On the other end of the spectrum, we're thinking about models and risk assessments, which have a lengthier development, but a greater depth of information. So as we're thinking about these different products and these different disciplines of science, we're thinking about which of these tools, which of these science advice products is best matched to provide the information needed to really rigorously evaluate these aquaculture opportunity areas and these environmental impact statements. So I'm just going to quickly breeze through these, but we're really building capacity around the country. We have science centers around the country that have specialized in different areas of aquaculture science. We're building capacity in the social sciences. We brought on an aquaculture social scientist that's really helping us to build a lot of capacity for analysis related to the social impacts of aquaculture. We have expertise in genetic risks. There's certainly legitimate considerations and concerns related to the potential genetic effects of fish escapes in different circumstances. And so we have experts at the Southwest Fisheries Science Center that provide and have built a model framework that can help us to evaluate genetic risks. And then in terms of engineering, we are building capacity related to aquaculture engineering, establishing and working towards guidelines, national guidelines for engineering activities, or engineering plans in the U.S. And where I want to land, which I realize I've covered a whole lot of ground, is that marine aquaculture really does have a bright future. Hopefully I've been able to convey that to you. There's a lot of different environmental drivers. There's a lot of different societal drivers that are moving us in this direction. But to do it right, it's really going to require strong science and a commitment to sustainability. I mean, this is a private sector activity. So it really does come down to the actions of individual operators and a strong regulatory framework to ensure sustainability. But to know whether or not we're doing it sustainably really requires that strong and robust science to understand the environmental interactions and impacts and benefits. And I also wanted to land on this. There's a wide variety of opportunities available through NOAA. As we're thinking about different grant programs as well as scholarships and fellowships. For those that would be interested in grants, particularly related to aquaculture, very recently there was a guide to federal aquaculture grant services that was published, which lays out all of the different grant programs across NOAA that focus on aquaculture. I actually think it includes programs outside of NOAA at USDA and other federal agencies, but I highly encourage you to check that out. If you just Google Guide to Federal Aquaculture Grant Services, it'll pop up. But that includes programs within NOAA Fisheries, where I am, programs at Sea Grant, the National Ocean Service, and others. And then for the students, I wanted to point you all towards some scholarship and fellowship opportunities. The NOAA Office of Education is the best place to find those resources. The Holling Scholar program is a really great program for undergraduates. It's both a scholarship and internship program. And then for graduate students, thinking about the Margaret Davidson Fellowship Program, that's a really great graduate research fellowship program that's been established. The Canals Fellowship Program gets you linked up with NOAA offices in the DC area, as well as other opportunities in the federal government. And then the NOAA Pathways Program is another one that really wasn't on my radar until I left grad school, but it's a really great program that gets your foot in the door for a potential NOAA career. So with that, I covered a lot of ground. Hopefully things were communicated clearly. I know we had that little snafu with the tech earlier. So really appreciate y'all bearing with me and your attention today. And thank you to the broad array of colleagues that are at NOAA and the Nature Conservancy and beyond that have contributed to this work. It's really a large and growing community, and appreciate y'all's time. And my email's here as well if you'd like to touch base.
Round of applause. I really appreciate that, and I'm glad we were able to work through the little snafu with the video, because I think that those slides were actually really important in terms of wrap up. I know we're over time, but I'm happy to hang on for 5 minutes and take any questions. You can feel free to put a question in the chat or just ask away. Tal, did you have a question?
Yeah, I can jump in. Hey, Seth, great to have you on board. I agree we need to get you down here at the coast. Yeah, I'll just throw a question out. I love the big perspective that you all have at NOAA, and then just thinking about more locally here in North Carolina. A lot of the stuff that I think about is most of the people doing aquaculture, doing other things. They're commercial fishing or doing something else at the coast. So how can we increase capacity to the people that are already doing it? And I love the kelps idea, the seaweeds and kelps idea. We're probably too far south for any kelps here in North Carolina, but are there any seaweeds like ulva or others that are being developed that can be cultured locally and be put into the portfolio of things that the people doing aquaculture are already doing?
Right. So a couple different dimensions to what you shared. So one is that I didn't talk about it, but there's a whole effort underway at NOAA and with the USDA, as well as the Economic Development Administration, focused on workforce development. And a lot of that work is thinking about building programs that are very similar to what y'all have right next door at Carteret Community College in terms of these opportunities for hands-on learning about aquaculture and really being able to get into the sector in that way. So there's a lot of work underway that I didn't share on the workforce development side, and that's really important. On the seaweed side and the other market-based opportunities, seaweeds is an area where there's a lot of expansive growth in both academic research and industry development. A lot of it's been focused lately on temperate seaweeds in the Northeast and Northwest. But there is growing interest in species like Gracilaria and other more kind of tropical seaweed species that would be more primed for production in North Carolina and further south. One of the challenges that when we're thinking about some of those other seaweed species is thinking about markets for them. So a lot of those other more tropical seaweed species are farmed globally for processing for carrageenan and other compounds at a pretty low cost. And so it's one of those things where we need to think about, growth of different industries and where the markets are for those different products. I know there's been interest in scallops in North Carolina, and I think there are other species along those lines that are in development and have potential. But seaweeds is definitely an area to keep an eye on, and I think that the growth and interest has largely, for the last several years in the U.S., been on the temperate side. But I'm beginning to see more interest in more of the tropical seaweeds and the types of seaweeds that would be more viable in the Southeast region.
So I missed it. Is anybody producing Gracilaria on a commercial scale?
Not that I'm aware of. There's a big program through the Department of Energy, the ARPA-E program, ARPA-E Mariner. And through that program, there's been a few projects. I believe the interest has largely been in Florida and Puerto Rico on Gracilaria and Euchaema as two species of interest. So there is some work, just not as much.
Yeah. And I haven't been here long enough. There's no chance that we can get like a 4 to 6 month window of saccharina production in the winter here. Is that
so honestly, Chuck Wyrick, who used to be based at CMAS, he's one of the 2 national sea grant aquaculture program managers. He's thinking a lot about aquaculture in the Southeast. He'd be a really good person to talk to about those questions specifically, because he's really thinking a lot about those issues. So I'd be glad to connect you up with him if you're not already.
No, I'm already. Yeah, I'd love to see that happen. Yeah, and that could probably get into selective breeding of, say, warm water kelps that'll fit into our small window of production.
Right.
And that's
so Scott Lindell at Woods Hole and Loretta Robertson at MBL are both 2 folks that are thinking a lot. Scott's thinking a lot about selective breeding of different seaweed species, and Loretta's working a lot more on the tropical seaweed side. But they're really, I mean, in terms of commercial production, it's extraordinarily limited of any seaweeds nationally in the U.S. And non-existent as far as I'm aware in terms of some of these other tropical, subtropical type species. Yeah. But we want to see that growth.
Thanks, Tal. Seth, I'm going to ask one question, and then I think we're going to go ahead and take a short break and then just resume with a few of the students. But one of our speakers this semester was Ben Reading, who runs the Striper Hub program, which is primarily land-based. So they've got these in-ground ponds, or they're almost like swimming pools, above ground swimming pools, and raising these striped bass, hybrid striped bass. And so your focus was on sort of in water, coastal to slightly deeper water aquaculture. What is the thinking in terms of NOAA aquaculture with respect to more land-based aquaculture, and I guess more land-based polyculture?
Right. So I didn't get into detail on the more industry-focused science that NOAA does. There's a lot of work that NOAA does related to breeding technologies, related to cultivation technologies. Didn't get to touch too much on that. But a lot of that underlying science is sort of agnostic to production systems. So some of the species that are being thought about and worked on could theoretically be viable in RAS, recirculating aquaculture system-based systems, land-based systems, as well as in actual net pen or in-water systems. So some of that science certainly translates irrespective of the production system you're thinking about. There is a major focus more on the marine aquaculture side because of the nature of NOAA in terms of our focus on NOAA trust resources and thinking about the U.S. coastal ocean. The work that I had done with the Nature Conservancy, we published a report that was really focused on thinking about different dimensions of aquaculture growth, thinking about the future production systems, and I believe fairly strongly that recirculating aquaculture systems do have a role to play. The challenge is largely around the capital intensivity of those types of systems. They're very expensive, and there's a number of projects that are underway in the U.S. and internationally that have not reached commercial viability. There's been major investments, and very few of those systems have actually succeeded in terms of actual commercial viability. So I think there's potential there. There's a number of questions. NOAA's not playing as much of a role in terms of specific research focused on land-based or recirculating systems. But it's definitely one of those areas where there's a lot of investment interest and potential that is there that has yet to be realized.
Right. Well, thanks, Seth. I think that's going to do it for us. Give Seth another round of applause or a little clapping emoji in